Cool, and I'm done. So that's another example. And again, I did a lot of validation here. So we've seen a certain validation here. If you look more closely in the request, so this is my request that has been sent as a part of load testing, and this is what I specified as expected data that needs to be validated for me. So every single request has some kind of different user that you can specify. You can specify the cookie, you can specify header as expected value. You can really look more closely at the HTTP runner service contract and see what you can get from it. So because we already touched on certain validation, and it comes with a very rich support for validation. So let me show you a little bit of this one. Okay, I've got some tests or pipeline. So this particular pipeline is inline workflow with the actual unexpected value. So CQ1 is value 1. So I've got the libc that simply it's broken. So let's see how that kind of gonna play with us. So immediately we see we're seeing some issue that, let's look into it. So it says that for key 2, value 20 was not equal value 2. So let's check it. Key 20 is not value 2. So for the key 3, value 30 wasn't equal value 3, and so on and so forth. And then also saying that I expected key 4, but actually the actual is missing. So I had all this information kind of human readable way, and you can have really nested path, and nicely I'll show you what is missing, what's wrong with the validation. The validation that you provided, Endly, it's kind of rule-based. You can provide either a complete object representation that you want to validate a data structure, or just partial validation. You can use regular expression, you can use various directives that really enhance your validation rules-based approach. Obviously, the simple validation you can test from your command line is like, okay, you provide actual and expected, so A is not equal B. It's super easy. But let's look at some data structure validation. Let me run this first, and then we look at the data structure. So again, it says that key 3 was missing. So let's look quickly at that structure. So my expected looks like this. So I've got key 1. So I've got 2 elements in the array. First element is key 1 v1. Another one is key 2 and key 3. And my actual looks like only key 1 and key 2 is missing. So in this case, because I'm validating array, just gives you an index and then attribute that is kind of missing. Okay, let's try another structure validation. So in this case, many frequently when you're dealing with the unordered collection, you need to have ability to specify exactly how to deal with those things, because order in the collection is not guaranteed. So the example is the example 2. So let's see what do we expect. So what we're validating, so let's see the actual value first. So we're validating an collection with 2 elements, with sequence 22 and sequence 11. And then let's say that is an order collection, so it could be in any order. So for me to validate this, I need to first specify the index, and then in the map is the array specify the key for that index and what the value would be for this unordered actual list. So let me go further down. So another example is of the switch case transformation. So again, we can go over actual value looks like this. So I've got experiment. Let's say, we had some A/B testing. Depending what has been selected, you may test different outcome. So I've got experiment 1 and sequence. So let's see how do we define this validation. So I'm just providing various combination for different cases. What will be matched depending on the experiment ID that being found in the actual data. Yeah, so that's really useful when you do some, A/B testing, machine learning things that varies. So let's go to the next example of validation. Is the asset part. As I said, you can do either partial or complete validation. You can also specify only the path that you're really interested in validating. So here's an example of another data structure, the data, which has the collection, and the meta, which is another map or object. And here just specifying what you want to validate, and you don't care about anything else. So this is your example. You had so much more when it comes to validation. If you really want to delve into it, just please go to Assertly, and there's the whole validation expression and much more example to go. So the next item that we need to cover is the execution control. We've seen already variable usually as a part of our expansion, that being expanded part of the request or message. But variable also can control workflow execution. Each action task have a when attribute when defines a criteria whether a given action executes or not. So let me first run this when and see what happens. So let me clear it. Okay, so you've seen hello from action 3. So we have 3 action 1, action 2, action 3. So the action first only will run if the P is equal B1. Okay, so and action 2 it's only will run if the P equal B2, and then action 3 will only run if there's hello txt, and in this case it looks like it is, and also I'm printing the content of that file. Okay, so let me try force the execution of action 1. So in this case I need to provide parameter P, and let me call it B1. So in this case I see action 1 and 3 being called, and then if I want to call action 2, I just call when P equal B2. So I've just applied that value. Okay, so it's very powerful. You can use UDF as a source, or just variable on its own. Another thing that you can do with the workflow, you can run certain action in a parallel. So here is an example. The action parallelization happens with the task, so you have to flatten all the action for the task. You need to set this multi-action attribute to true. So in this case, those action will be part of that task as opposed to subtask with an action. So let me quickly run it so we can see the free action. It sleeps 3 seconds. So if I run it sequentially, everything will take like 9 seconds. But if I run it with the asynchronous flag, everything shouldn't take more than 3 seconds, right? So I had to flare from action 3, and everything taken almost 3 seconds. Okay. Okay. So here we can see I've got my action 2, which is flag async true. I've got action 2, which is not synced with the sync, which is kind of run immediately. You can see hello from action 2, and then action 3 also is asynchronous. So action 1 and 3 are asynchronous. So you pretty much wait for the outcome once they fully execute, and then you see exactly what they're written back. Okay. Another important thing with the workflow is the defer execution. So sometimes you want to operate certain resources, like example, you want to start your Selenium, but you want to also make sure that you nicely stop all the Selenium runners or services. So in the defer action, no matter whether there's some error or not, you want to always nicely define action that will release those resources. So if you look at the execution of this defer, yeah, so you can see hello action 1 always run, but now I can actually fail. So let me define fail now 1, variable fail 1. So now you see there's exception, and I still run the defer task, which is called, which is print always run. If there's an error with the workflow, if you don't define the defer, the workflow execution ends, and then that's pretty much it. So you can also try to catch error. Sometimes that error might be okay, like I don't know, you want to delete table that may or may not exist, and it doesn't matter if it's not there, but if it's there, you want to delete it. So you will see an error, but you can catch it, and in this case, workflow still execute, right? So we can quickly run this guy, see how that works. Yeah. So control error. Yeah, we see hello action 1, hello 3, hello action 2 and 3, and now again I'll try to run it. We fail now. Does it fail now? Oh, P, that has to be P equal fail now. Okay, so we failed, but we still executed, we caught it, we just print a message, what went wrong, and we still executed next action, which is the hello task 2 action 1, okay? And then finally, you know, sometimes it may happen that, for instance, you want to push multiple message for prepare your, you know, message bus, or you want to validate, you know, multiple files. So sometimes you may use still a loop. So the loop construct is very simple. It's just, you know, you have your variable. I'm using the self namespace. In this case, the self never collides with another workflow, especially if you load one workflow from another workflow. The data substitute is like golden standard. So if you have $I defined here in your sub workflow, when you loaded it, it's gonna be expanded immediately. So if you want to avoid collision and kind of be sure that this is not shared with another workflow, you can always define the self namespace to keep this variable. So let's see what happens. So I've defined the self variable and I have a task loop and I have just info, just say, okay, I'm pushing, I'm doing something. And I've got the increment action, which just do post increment on self I. I'm just assigning to like, you know, almost empty underscore variable. And I'm saying go to the loop task, to this task, when self is less than 10. So I'll go over 10 times here. At the end, I'll just print done. So let me quickly run this workflow. And that's it. That's the simple loop. So the final thing, debugging and troubleshooting. When dealing with workload, sometimes you want to really see, you know, all the action contract services and steps, you know, state modification. In this case, you can run -d, and you will see that there's extra folder created called logs, and for every execution there's, you know, all the detail information about every single action. And if you go down, you can see, you know, how your workflow looks and so on. So every single action, every step modification will be listed there, right? Another thing that you might be interested in is to see kind of workflow as a data model. So every single workflow, as I said, goes to the task, action, and so on. So you can nicely see it, how this kind of being laid out here. Okay, so you've got the task, you've got you know, another task. So you can see this nested structure of the domain model for the workflow. So you can nicely debug it and troubleshoot with all the data as being kind of created. So if you really want to see this example, maybe nice workflow to look at, much more complex, would be the one that loading the data for the stress test. So in this case, this workflow may look something like that. Okay, so much more complex, but you can see that the data is all those your requests being kind of loaded per different use cases. So this is the tag ID, this is the data loaded, so you can really see what's going on, how this data being transformed and loaded to your workflow. And the final thing, you can also use GoPS if I need to get this installed, and then you can use the stack to see where end is at any given time. So thank you for spending time for getting this presentation, and hopefully enjoy working with Endly.